The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hello and welcome back to the Ben Heck Show. Over the years, I've made many video game consoles and old computers into portable versions of themselves. One I've never gotten a crack at until now is a ZX Spectrum. This is kind of hard to find in America since this is mostly a UK, Europe computer. So we're going to take it apart and see what we can do with it, but we have to be careful because this is the only one we have. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
I only have one ZX Spectrum, so I don't want to break it. Therefore, we're going to do this project in several steps so I have the time to do it right. The overarching build is to take it apart, modify and compact it, add modern storage such as an SD card instead of a cassette tape, make a new keyboard, and of course find a way to get a better display out of it. Then we will try to make it into a compact laptop or a handheld form factor. So in today's episode, we're going to take the unit apart, examine the components, try to get it running off of a modern voltage, see if we can get a video display from it, and replace whatever components we can to start with. Here it is, the Sinclair ZX Spectrum, or as they say in other countries, ZX Spectrum. Not sure why. So this was the whole computer, although you would need a tape drive to go into it to get your programs. But there's also an expansion bus, which is used quite a bit. There isn't even a power switch on this thing. So the way I acquired this was I basically went begging. I went onto Twitter and said, hey, I want to do a project with the ZX Spectrum. Does anyone have one they could send me or sell me? And a fan from Ireland sent me one. They're kind of hard to find. Even on eBay, there's only a couple available, so I was very lucky that someone sent me one. So the keys, there's not very many keys, and each key has like, what, 5 functions? That's insane. So this rubberized chiclet keyboard is definitely something we're gonna want to try to improve. All right, let's take a look. All right, so this is probably going to be row and column. Let's see, here's the CPU, the Z80. This, I believe, is the multi-purpose video drive chip. The video on this was pretty simple. You had, I think, like 8 different colors, and there could be bright or dim versions of each for about 16 different colors. And then on any character on screen, you can only have 2 of those colors, one or the other. So it was kind of limiting, but they could also do some pretty cool graphics as well. If you ever look online, they have people still make art with this thing. Had a very bright, posterized look to it. So this is going to be your RF regulator coming in the side here. These are probably going, well, this thing didn't output sound to the television, so probably, actually it looks like there's just, is there 1 or 2 here? One of these is probably going to be our composite video in. Now this was from the UK, so it's PAL signal, not NTSC like we have here in America. However, I should have some LCDs that are NTSC and PAL compatible. Most LCDs made in the last decade actually are. This right here is a heat sink. There is, you know, bog standard 7805 linear voltage regulator. So this takes the 9 volts in, knocks it down to 5. So you don't really need any special European power adapters for this. You just hook voltage up to it and it will work, because voltage is the same in different countries. You know, 5 volts DC here is 5 volts DC in England. So this had 2 banks of RAM, I believe. This is one of the banks, and this is the second bank. So there was a 16K model of this and a 48K. And this is the 48K model because it has both banks. And another thing they did to save money was they actually used defective RAM chips that only had half of their capacity working. These are 64K chips, but half of their addressing doesn't work, so they're actually only 32K chips. So you've got your 16K base plus 32, 48K. Anything to save a buck. And the speaker is, all it basically does is pop on or off. It's very rudimentary, although people wrote routines over the years to increase the sound greatly. And if we're gonna make this into some sort of portable, there is a nice expansion bus here on the back, which should have pretty much everything on it. I'm not sure if anyone's actually made a SD card or compact flash disk emulation system for this, because this mostly used tapes. You would load off a tape. However, one thing we could possibly do is create a circuit that would simulate the tape. So it would send in all of the, audio files into this. This thing was designed to work with any tape player you had. If you had like the Commodore or the Atari, there was a Commodore tape player or an Atari tape player that you needed. With this thing, you just plug in whatever tape player you had right here, and the data transmission was very liberal, allowing for variations in the tape. Even if the speed wasn't correct, it could compensate for that, which is pretty cool. We'll have to look into that. I guess what we could do is we could find a tape player and try to load a program onto this. All right, let's see if we can get this out of the shell. I've built many different 8-bit computer mods over the years. I've done an Atari 800 a couple times, and a couple Commodore 64s, Apple IIgs, and I think that's it. So this is me reaching out across the pond. One screw held that in. All right, how do we get this keyboard apart? Let's try these tabs here. Oh, I see, this metal plate comes off. That makes sense. Even though this thing was made very cheaply, still wasn't glued together like modern electronics. What does that say about us as a people? We're definitely gonna have to keep this Sinclair Rainbow. This is pretty normal stuff. It's a masterpiece of cheap design. I don't know if I'm gonna reuse these keys or not. They're kind of iconic, but they're also kind of mushy. I think I'd like to take my own stab at it, because if we're gonna rebuild this, we might as well remake this. We're not gonna use this. So, I like this though. This is really cool. See, around this time, Commodore 64 or Atari would have had a full mechanical keyboard, and this was cheaper. I mean, they still use this today in keyboards because it works. But man, this thing was just so efficiently built. It was like the people's computer. It was a Volkswagen of computers. Now it's time for a tech timeout. Today's tech timeout, let's see what we can do with an oscilloscope. We recently got a Tektronix MDO3104 oscilloscope. It's really nice. And I'm using it to analyze the luminance signal coming out of the ZX Spectrum video chip. So here's what I did. I used the oscilloscope to actually capture images to a thumb drive, and I'm going to lay them over each other here in Photoshop, and then I'm going to draw red over all of the signals. Okay, see that? So this is actually the individual scan lines that were captured by the oscilloscope. If I take that red text and compress it, hey, look at that. It is the text that's on the display. So analyzing this video signal, saving the data to a thumbstick, and then analyzing it in Photoshop was a great use for an oscilloscope. Hi, I'm Ben Heck, and today we're going to talk about 3D printing. This is way over-engineered. I guess you could recycle it, but I would need like a chipper. One thing nice about the laser cutter is it makes a great table as well. PlayStation 3, Wii, Xbox 360, that was easily the greatest generation of games ever. This would probably do some damage to your eye, or at least, give you a headache. I used to be able to beat Contra without dying. This actually shoots out 3 different laser beams in red, green, blue, so you can actually use this in theory to paint a photo. Basically just a vacuum chamber, and you go. How many times have I burned myself with a soldering iron? Many? You could point this at a chip and see if it's hot. Even like 7 years ago, I wouldn't have been able to do this. I'm Ben Heck, and these are my bins. I don't know what I'd ever use this for, but I have it. Well, I think this is a good place to stop talking. I'd like to be able to put custom ROMs onto this ZX Spectrum. Now there's a big community for ZX Spectrum on the web, specifically World of Spectrum, which is the top site. Most old computers have, user groups still. So I was able to find both the original ROM, which is basically the operating system. It's a 16K operating system, contains all the characters, basic language, and I've opened it here in a hex editor. Then there's also a new ROM called Gosh Wonderful ROM, and it has some improvements such as you can type out words instead of having, keywords. And it's the same size, it's also 16K because that's all the bigger the ROM is. I thought, hey, what if I combine these? I have this 32K EEPROM I pulled out of an old hard disk, so that's what I'm gonna do. Now the EEPROM, a 32K EEPROM obviously has two 16K banks in it. The Sinclair's only gonna look at one at a time, so we could actually select between top bank and bottom bank, so you could have a switch which actually toggles which custom OS you're gonna use. So here's how I'm gonna do it. I'm gonna take the custom ROM, the Gosh Wonderful ROM, I'm going to select all, I'm going to copy that. Okay, I'm gonna go over here, this is the standard ROM, it'll be the first one in memory. And I'm gonna go to the end, and I'm going to insert the data from the second ROM. Here in hex we see 7FF0, that means it's basically at the top of 32K. And if we go halfway through, we see, here's where I pasted the data. It's all in red. So if we disable the first bank by having A14 be 0, you won't see this. The computer will think this is the start of it. So we can actually have a selector between banks. So I'm gonna actually save this as a custom ROM. I'll call it dual ROM. All right, now we can burn this image to our EEPROM, and I'm gonna use the atronics USB EEPROM programmer that I got from Element 14. Okay, the chip is programmed and there's a piece of tape over it so that the sunlight doesn't accidentally erase it. Now we're going to modify the ZX Spectrum so we can stick in this larger EEPROM. Let's try and use the ZX Spectrum. So here's the motherboard. I have this little screen here that I got off the internet a while back. We used this for a project, but I bought several of them because they were cheap. And this screen can do PAL and NTSC, so it should be able to do the spectrum. So I've got 9 volts going into the screen, and that's also what we need for the spectrum. So this right here was the composite signal going into the RF box. I disconnected it because we don't need the RF box. So I've got that going back into the screen. I'm going to tie the spectrum's ground together. All right. Now let's plug in the keyboard because we'll need it to load from tape. Let's see what happens. Ah, there it is. Okay. Now this in itself is not very interesting. I mean, I can type things. Variable not found. Okay, let's see. Print. Hello. Oh, it worked! Well, obviously I can program a game on the Sinclair now. So what I'm gonna do is I'm gonna use a program that simulates the tape drive this used to use. Most people use tapes with this, not discs. And the tape would play an audio file that would be converted into zeros and ones and load the program. It's kind of slow though. So I've got my laptop here. Ta-da! And I found this program called WinTZX, which means it's a tape ZX format. And I found a few files online. The Batman seems to work. It's the Batman. So what I'll actually do is I'll get my laptop here like this. I will plug in the headphone jack of the laptop. Where's the headphone jack? Oh, there it is. Okay, now that's in stereo. And I wired it to this to turn it into mono just to make sure the signal was loud enough. I have my computer turned all the way up. And now I'm going to plug this into the ear jack. Oh, this video signal is not very good. But these scrolling lines here show us that the tape is loading, and it should tell us the name of it here once it gets the header file. And it's also repeating it through the speaker on the Specky. I'm just going to call it the Specky because that's easy. I believe that's the cool thing to call it. Hey, want to come over and play some Specky this weekend and eat crisps? Yes. don't need the laptop since it's loaded. I don't think this is a multiple load program. Let's see. I don't have a Kempston joystick. Okay. Great. Let me in the game. Oh, here we go. I'm Batman. Now it looks like you use these two keys to go left, up and down, and then these go left and right. Remember the part in the Batman movies where he walked around, it went doop, boop, 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 boop. Oh crap, are those bad guys? Run away! Oh no, I'm dead. Run away, Batman! Well, the system definitely works. Maybe I'm just supposed to avoid these guys. We know this ZX Spectrum works, so now I'm going to change things with it. The first thing I want to try is putting in a new ROM. This has the standard OS at the first 16K bank, and then something called Gosh Wonderful OS on the second 16K bank. I don't know if you remember when I was pushing those buttons, it typed out an entire word when I pushed one button. The new ROM makes it more logical where you type in load, L-O-A-D, instead of hitting J. So I'm going to try to put this onto the board. I was never really into the ZX Spectrum because I'm American, but I think it's a really cool system and I'm trying to learn as much as I can rapidly. I'm going to mount this socket above the surface so I can break some of these points. There's some Schottky diodes in here that go for the chip selects. So this is, I'm not going to try to make this small right now. I'm just trying to have options. What I'm doing here is converting the socket. So instead of taking the original ROM, it can take an eeprom, or I just like to say eeprom, that I've programmed. Now I'm attaching the new socket. They do make sockets with long leads on them, but I didn't have any of those, so hence this hack. Now I'm going to electrically test this to make sure all these connections are correct. That way if it doesn't work later on, we know it's not a connection. I've used this compact switching regulator in place of the 7805, that way we don't need the big heatsink. And here is my socket. I believe it's ready to go, so I think we should give it a test. I'm glad I pulled that 20-year-old hard drive out of the back of my mom's car that one day. This is a 32K EEPROM, and it's replacing a 16K ROM. So there's basically two images on this EEPROM right after another. So address lines 0 through 13 will give you access to the first 16K. A 14 basically selects which 16K bank, the first one or the second one. So we can't leave this unconnected. It either needs to go low, which means the first bank, or high, which means the second bank. But that means we can actually put a switch on it so you can select which bank you want to boot into on startup. At least I hope that works. I've got this switch here. It's got 2 poles and a center pole. I'm going to attach the center pole to the A14 line. And then these, I'm going to have one going to ground and one going to 5 volts. So basically the switch allows you to set if A14 is high or low. Again, I'm not trying to do this to be purdy, I'm just trying to do it just to test the concept. The first bank has the original stock ROM. The second bank has the Gosh Wonderful ROM. So let's start it up on ROM 0. All right, now the difference between those is the original ROM, if you push a key, it'll type an entire word like load. So we would do that in order to load off the tape. Okay, I've also added a reset button. I still need to fix the video, it's pretty bad. All right, so I'm gonna put the processor into reset. I'm gonna switch this to bank 2. And it looks the same, but the difference is if I hit J, we just get the letter J. We don't get, the word. I actually have to type out load. So yes, we can switch between the original ROM and the new ROM just by using an EEPROM that was twice the size. And it's mostly pin compatible. We just removed the one pin that was different, which is the A14 line, which makes it 32K, not 16. The last thing that I'm going to fix today is the video RAM. The video RAM went here, and clearly I've removed it. The reason I want to remove it, A, it takes up a lot of space, and B, these RAM chips use positive 12 volts and negative 5 volts and positive 5 volts. 3 different voltages. I've actually ran into this before with old systems. I believe the ColecoVision did the same thing. Over here, there's some circuitry to step up the 9 volt input to 12 volts and also create a negative 5 volt, but it would be better if it just used 5 volts. So I removed the chips, and then this is the video chip, and it accesses the RAM. I found an article online about how to replace the RAM. So this is what I did. I made this little breadboard here, which could possibly replace the entire ZX Spectrum. I could basically rebuild the computer on this breadboard, and maybe I will. But for now, it's my RAM test. This socket is wired to the RAM chips behind this board. And these jumper wires basically allow us to virtually plug in this expansion RAM into the video chip. So I can still use most of this board and test this part. So we have a 32K SRAM, a flip-flop, and a NOT gate. And what happens is this actually accesses the memory 14 bits, and it does it 7 bits at a time for row address select and column address select. So what the flip-flop does is it basically latches 7 bits of the address and then latches the other 7 bits of the address. And it allows us to connect a modern SRAM that I bought off Element 14 to the Sinclair Spectrum, and this RAM only requires 5 volts. Let's see if it works. Let there be semiconduction. All right, the fact that we can see text on the screen and not a garbled mess means that the new video RAM is working. Well, that's all we're going to do with this project for this episode, but in a future episode, we're going to come back to this and further enhance it and eventually try to get it into a portable form factor. In our next episode though, we're going to be working with Minecraft, specifically trying to make real-world cubes to simulate the logic that people build in Minecraft game. We'll see you then. Oh, I forgot to hook up this. I guess we won't see what happens yet. But you don't have to take my word for it. Okay, so boring wiring ensues.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.